In this video, we will learn how to compute expected frequencies for contingency tables. Fundamental attribution error, FAE, is the terminology psychologists use to refer to the tendency of a person to overemphasize dispositional factors and to underemphasize situational factors when attributing reasons for other people's behavior. We are interested in seeing if there is a difference in inclination to commit the FAE among groups that differ in level of psychology training. We choose 3 groups of adults to participate in a study: adults who have no psychology training, adults who have a psychology degree but who are not practicing psychologists, and adults who are practicing psychologists. We show each participant a videotape on which a scenario is enacted, and we ask the participants questions about why the characters in the enactment behaved as they did. Suppose that our data are those summarized in the table below. The table is a contingency table showing the classification of each of the 150 participants according to the 2 characteristics: level of psychology training and type of attributions emphasized. In the cell of the table are the respective observed frequencies, and 3 of the cells also have blanks. Fill in those blanks with the frequencies expected if the 2 variables, level of psychology training and type of attributions emphasized, are independent. Round your responses to at least 2 decimal places. Assuming that the 2 variables, which are level of psychology training and type of attributions emphasized, are independent variables, we can compute expected frequencies by the following formula. Multiply column total by row total and divide that product by the table total. We are asked to find expected frequency for the 3 cells that are located on the diagonal from the upper left-hand corner of the table to the lower right-hand corner of the table. To find the expected frequency for the first cell with the observed value of 10, we multiply 31 by 59, which are my totals for the column and row, and divide by 150. This results in 12.19. For the next cell that has 21 as an observed value, we need to multiply 51 by 54, which are the totals for the column and row, and divide by 150, which gives me 18.36. Finally, the last cell has observed value of 17. To find the expected, we need to multiply 68 by 37 and divide that by 150. The resulting quantity is 16.77. This topic of computing expected frequencies in a contingency table is used as one of the steps in a test called chi-square test for independence. This particular exercise is asking us to compute only a sample of 3 expected frequencies, but in reality, for the purpose of that test, you would have to complete all 9 expected frequencies, which are later added to give us a test statistic.